Yes, yes, sure, I'll join. Plus, yes, yes, sure, I'll join. Plus, okay, let us continue our discussion with respect to S-curve hydrographs. Yesterday we started S-curve. Okay. So we discussed about how to find out equilibrium discharge of S-curve. This equilibrium discharge. So this equilibrium discharge of S-curve you can work out by using equation 2.77 A by D. Using this equation you can find out. That's what we learned. Then before we talk about S-curve, so let us know how to construct this S-curve. Okay? How S-curve is constructed. So to construct S-curve, we badly need one T-hour, D-hour unit hydrograph. Construction of S-curve. So S-curve is constructed with the help of D-hour unit hydrograph. S-curve hydrograph is constructed with the help of D-hour unit hydrograph. So you require badly one D-hour unit hydrograph, without which S-curve is not possible. So S-curve hydrograph represents a storm of infinite duration. We all discussed about this. S-curve represent storm of infinite duration, and it is constructed by method of superposition. And it is constructed by method of superposition. So that means infinite duration storm is divided into infinite number of D-hour storms, assuming that they are occurring in succession. They are occurring in succession. Succession means one after the other. each with a time delay d hours. So then what we do is we superimpose d hour hydrographs one above the another, each with a time delay d hours to obtain S-curve hydrograph. So superimpose d hour hydrographs one above the other, each with a time delay d hours till it attain equilibrium discharge. So once it attain equilibrium discharge, further superimposing also doesn't make any difference till it attain equilibrium discharge. So as per the procedure, what you need to do? You need to do, you have to superimpose d hour unit hydrograph, each with a time delay d hours. This is first d hour unit hydrograph. Then this is second d hour unit hydrograph. And this one is third d hour unit hydrograph. This one is fourth d hour unit hydrograph. This one is fifth d hour unit hydrograph. How long you need to do it? Till it attain equilibrium discharge. This is sixth d hour unit hydrograph. So you keep on superimposing this. How long? Till it attain equilibrium discharge. So each with time delay d, 2d, 3d, 4d, something like this. Then if you combine all these d hour, each d hour unit hydrograph represent d hour storm. Each d hour unit hydrograph represent what? One d hour storm. So this is for first storm, second storm, third storm, like that. So how many hydrographs are superimposed? Truly speaking, infinite number, but infinite number practically not possible. Therefore, finite number only we superimpose. This is first storm. This for first storm. Second storm indicated by red color. This is for second storm. This is second storm. Third storm, yellow color. This is third storm. Like this, infinite number of d hour storms, they occur in succession, one after the other. Next one, green color. So each one represent d hour storm, d hour storm, d hour storm, something like that. So something like this. So infinite number of hydrographs if you superimpose, finally you get what? So it is continuously superimposed, no end for it. So the cut section I am showing. So each with a time delay d hours, 2d, 2d, 3d, something like this. So each with a effective rainfall intensity 1 by d centimeter. How long? Infinite time period. So this is actually nothing but method of superposition. The resulting combined hydrograph produce S-curve hydrograph. So if you sum up all these things into one, then you will get one S-curve hydrograph. How we can sum up? This is the S-curve hydrograph. If you smoothly combine all these hydrographs into one, you obtain one S-curve hydrograph representing a storm of infinite duration. Okay, I'll draw. Finally, you get like this. Okay. This is S-curve hydrograph up to this. Okay. You will get S-curve like this. So this is first storm also there, second storm also. This is first storm. Right? This is second storm. right? This is third storm. All these storms combined into one S curve. How long? Till it attain equilibrium discharge. Till it attain equilibrium discharge, we combine them. So once it attain equilibrium discharge, further addition is not required. Okay? Further addition is not required once it attain equilibrium discharge. So finally what we obtain? One S curve we obtain. This is our S curve hydrograph. So this S curve hydrograph represent a single storm of infinite duration. Now it become single storm of infinite duration with effective rainfall intensity 1/d centimeter per hour. Here also all those things are there. 2D, 3D, same, 4D, etc. So the resulting combined hydrograph is S curve. Finally we got S curve. So once you get S curve, then you can use that S curve to construct a T hour unit hydrograph. So our intention is what? Not drawing S curve. So our intention is finding D hour unit hydrograph. How this can be done mathematically? The technique you have to learn. So it is nothing but method of superposition only. So I'll explain you shortcut also. The method one is nothing but like superposition method only. So let us assume. Let me explain this with the help of one example. Okay. So it is. So you have been asked to find out the S curve hydrograph. So find S curve or derive S curve, otherwise not find. Example, derive S curve from the given D hour unit hydrograph. Question could be like this. So we will give you D hour unit hydrograph with ordinates and all. Just 1 minute. బాలాజీ నేను క్లాస్ తీసుకున్నాను, నేను క్లాస్ అయినాక ఫోన్ చేస్తాను. Yeah, good afternoon all of you. So this will be given to you. This is one D hour unit hydrograph with ordinates are given to you. Ordinates also I will choose for our comfort and convenience. This ordinate A, this ordinate B, this ordinate C. 0, D, 2D, 3D, 4D. This is one D hour unit hydrograph. With the help of this, you have to construct S curve. Okay? So I am applying method of superposition. So if I apply method of superposition, how I can construct? So same as superposition technique only. So now we need to add so many number of unit hydrographs, D hour unit hydrographs, one above the other, each with a time delay D hours. So okay, it is superposition technique only. So method 1. Let me apply superposition. How long you need to apply method 1 superposition? It is just like that. The only problem is in between you have to measure whether it attained equilibrium or not. So if it attained equilibrium, you can leave it. It doesn't attain equilibrium, you have to continue further. This is for first storm. This is for remaining storms. Delayed D hour unit hydrograph ordinates. In between you have to verify, and finally you have to attain D hour unit hydrograph ordinates. So this is method 1. The first one is first storm, this is for second storm, this is for third storm, this is for fourth storm. You keep on doing like this until it attain equilibrium discharge. This is method 1. How to construct S curve. Method 1 is little bit complex method, but this is already we know this procedure. Superposition method. S curve also like superposition method. This is time. This is for first storm. D hour unit hydrograph ordinates. This is delayed D hour unit hydrograph ordinates. First one is D hours delayed. Second one is 2D hours delayed. Third is 3D hours delayed. Fourth is 4D hours delayed. In between you have to verify. Then finally you get S curve ordinates. So we don't know when exactly to attain equilibrium discharge. In between you have to verify. So first only we know. This is 0, D hours, 2D hours, 3D hour, 4D hour. These are the ordinates given. 0, A, B, C, 0. The first one is D hours delayed. D hour delayed, D hour into hydrograph ordinates. This is D hour, second stamp. Second stamp is D hours delayed. So therefore 0, A, B, C, 0. So one more extra ordinate you will get. This is second stamp. I am talking about this stamp. Here you can see there. You can see this. This is second stamp. Second stamp ordinate started to D, ended to first stamp ordinate started to 0, ended 4D. Second stamp ordinate started to D, ended to 5D. Something like that. Okay. So it ended 5D. Third stamp 2D hours delayed. So it's exactly started 2D hours. 0, A, B, C, again 0. So one more extra ordinate you will get. So in between you have to verify whether it attained equilibrium or not. So if you sum up all these three stamps, first stamp, second stamp, third stamp, okay, A, 0, A plus 0, A, B plus A, C plus B. So it is not attained equilibrium. So you have to do it. So if you sum up all those, first stamp, second stamp, third stamp, something like that, you will get S curve ordinates. So 3D hours delayed it is. So 3D, exactly at 3D, 0 start. So 0, A, B, C, 0. In between you have to verify whether it attained equilibrium or not. Equilibrium means what? Ordinate is repeated couple of times. Till that peak ordinate repeats couple of times, then we have to do it. So 0 it is A, B, A, C, B, A, C, B. Ordinate repeated, you can stop here. So it attained equilibrium after 4 stamps. Once first stamp, second stamp, third stamp, fourth stamp. Fifth stamp is not required. After attaining equilibrium any number of times, if you superimpose, it remains with same ordinate. It doesn't change further. 0, A, B, C, 0 again. See now it doesn't change. So 0, A, B, A, C, B, A, C, B, A, C, B, A, C, B, A. Forever it remains C, B, A. So ordinates are 0, A, it is B plus A, C plus B plus A, again C plus B plus A, again C plus B plus A. So once it attains equilibrium, forever it remains with equilibrium only. Any number of times you superimpose. Therefore S curve ordinates are 0, A, B plus A, C plus B plus A, C plus B plus. You can also superimpose like this. The superimposing can be done this way also graphically. You can also superimpose like this. You want to see along with ordinates, you can superimpose like this also. So this is for first stamp. The first stamp ordinates are, okay, ordinates I will put in red color. This is A, this is B, this is C. So this is for first stamp, this is taken as a reference line. For second stamp, I will take this as a reference line. Okay, this as a reference line. This line, hydrograph peak as a reference line, 0 line. So this is superimposed here. Okay, let me remove that red color. It is, I'll take some other color. This for second stamp. The again ordinates are, right? Again ordinates. This is A, not visible, no? I'll take this color. A, B, C, 0. Third stamp, this is taken as a reference line. So it started to D hours. Third stamp started 2D hour. This as a reference line. So this is unit hydrograph for third stamp. The ordinates are now, again, this is A, this is B, this is C. Fourth stamp start where? At the end of this one. 4D hours. This started 0, this started D, this started 2D, this started 3D. Somewhere here it started. Fourth stamp. The ordinates are again, right? This is A, this is B, this is C. Ordinates are repeated, no? CBA, CBA. So once it attains equilibrium, then smoothly if you join the curve, then you obtain S curve hydrograph. So you already attained equilibrium discharge. So that equilibrium discharge of S curve is, it is C plus B plus A. See, now we can see the ordinates now. 0D, 2D, 3D, 4D, 5D, 6D, forever. At 0, 0. At D, A. At 2D, B plus A. At 3D, C plus B plus A. At 4D, C plus B plus A. Forever it remains with C plus B plus A. That is called S curve technique. Understood? But this is too difficult to follow. Method of superposition in the exam. So there is a shortcut for this. Using that shortcut you can work out. That shortcut to follow, you have to follow this diagram. Okay? Let us learn the second technique. Method 2. To draw S curve. This is a shortcut method. In 3 steps you will get answer. So actually what we are doing? We are superimposing. This is first hydrograph. First hydrograph we draw here. With ordinates A, B, C. 0, D, 2D, 3D, 4D. Right? Second hydrograph start where? Above the first hydrograph. We draw here. This second hydrograph. The ordinates are, if you see the ordinates, this is A, this is B, this is C. Now, see the diagram. Third hydrograph start where? Somewhere here. Then again ordinates are A, B, C. So we keep on doing this till it attain equilibrium discharge. Fourth hydrograph start where? Somewhere here. What are the ordinates for fourth hydrograph? These are the ordinates. A, B, C. So it attained equilibrium now already. C plus B plus A 2 times repeated. Now let us see this technique. Carefully notice. So this is a shortcut method. This shortcut method is based on this. So it is a 3-step answer. So shortcut only we follow most of the times. Okay, here only 2-step answer. Time, this is D hour, unit hydrograph, ordinates, this much also not required space. Let me adjust. Okay, so this is S curve additions. Put one extra column here. This is S curve ordinates. Understood? Good evening all of you. Are you following this concept? Okay, the first step only crucial, very crucial, that is simple only and very crucial also. So this is 0, first term, D hour, 2D hour, This for our comfort and convenient, I took time intervals also D hours. 0, A, B, C, 0. See now, till the D, second hydrograph connected with first hydrograph only after D hours. So therefore, between 0 to D, whatever ordinates are there for first hydrograph, they straight away become S curve ordinates only. So above D, how many ordinates are there? This is D. Here time interval is D. Above D, how many ordinates are there? Only one ordinate is there. That straight away become S curve ordinate at D hour time interval. So it is 0. Okay? S curve ordinate at 0 hour time interval, that become S curve addition at D hour, join with the first stem hydrograph ordinate, D hour into hydrograph ordinate. 0 plus A, 0. That means this become S curve addition in the subsequent time interval and join with the first stem hydrograph ordinate, and it become A plus Z, 0. A plus 0, 0 has got no value, therefore it is taken as A only. A plus 0, it is A. Actually it is A plus Z, 0. Then that is A is the S curve ordinate at D hour. S curve ordinate at D hour become S curve addition at TD hour. At 2D hour S curve addition is A, that join with first stem hydrograph ordinate B, and both of them together become S curve ordinate at 2D hour time interval. That means this will go and join with the next level hydrograph ordinate. So B plus A, this become B plus A. B plus A become S curve addition at 3D hour time interval, join with the first stem hydrograph ordinate C, and all of them together become S curve ordinate in subsequent time interval. So this become C plus B plus A. Then C plus B plus A become S curve ordinate, S curve addition at 4D hour time interval, join with 0, and again it becomes C plus B plus A plus 0. 0 has got no value, therefore ordinate is repeated, it at a equilibrium discharge. So after that, any number of times it is C plus B plus A only, because there is no more ordinates are there. So it remain with the C plus B plus A only. So you can see which is simpler, easy method between these two. This technique you have to learn. So it's 0, A, B plus A, C plus B plus A, C plus B plus A, C plus B plus A. Here also we got the same 0, A, B plus A, C plus B plus A, C plus B plus A, C plus B plus A. Isn't it? So which is easy method between them? Which is easy? First method is easy or second method is easy? Come on, comment there. So you have to learn second method only. So finally we get, if you join all these ordinates into one single hydrograph, then we'll get S curve hydrograph. This is S curve hydrograph. So S curve hydrograph ordinates. Finally, the equilibrium discharge is how much? C plus B plus A only, forever. So C plus B plus A, C plus B plus A, C plus B plus A. You keep on doing like this. Understood? So this technique you have to learn. So construction of S curve is very, very important method. Clear? Comment there. Okay, let me take one example. So with the help of example, better you can understand this technique. The ordinates of four-hour unit hydrograph are given below. Construct S curve. Construct S curve means what? All ordinates you have to find out. So he has given time in hours, then 4-hour unit hydrograph ordinates in meter cube per second, of course. So every 2-hour time interval he has given. ordinates. 0, 2. This is 0, D, 2D, 3D, something like that we took, no, like that. 4, 6, 8, up to 20 is given. Zero, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The ordinates given are 0, 6, 33, 90, 119, 103, 79, 50, 25, 7, 0. These are the ordinates. Okay. You have been asked to construct S curve and also find equilibrium discharge of S curve. And second, catchment area represented by this hydrograph. Three questions are there. First question is construct S curve. Second question is find the catchment equilibrium discharge of the S curve. Third question is also find the catchment area represented by this hydrograph. So this many are there. So what to do? I use second method. First method you want to use, so it takes so much space, so much time is required. So let us use shortcut method and work out. Okay. So shortcut method to work out, you have to open up a table. So many ordinates are there. What happened? So let us work out. So this is time in hours. This is S-curve additions. So every 2-hour time interval ordinates are given. So the ordinates given are 0, 6, 33, 90, 0, 6, 33, 90. 119, 103, 79. 119, 103, 79. 50, 25, 70. 119, 103. 50, 25, 70. These are the ordinates. Okay. First step is very crucial. So what you need to note is this one. What is time interval of this one? 4 hours. First hydrograph start at 0, end at 20. Second hydrograph start at 4 hours. 4 hour delayed it is. So above 4 hours. This 4 hours, above 4 hours. How many ordinates are there? The 2 ordinates are there. The 2 ordinates straight away become S-curve ordinates. At 0 hour, 2 hour. So S-curve ordinate at 0 hour, 2 hour are, it is 0, 6. The 0 and 6, they do not remain there. They travel again. So these two together travel to the next level and join with the next level hydrograph ordinates. 0 and 6. Go to next level, join with these two ordinates, and all of them together again constitute S-curve ordinate at 4th hour, 6th hour. S-curve ordinate at 4th hour, 6th hour are 33 plus 0, 33, 90 plus 6, 96. Again 33, 96 become S-curve ordinates in subsequent time interval. So 33 and 96. 33 and 96. And all of them together constitute as S-curve ordinates at subsequent time interval. 119 plus 33, it is 152. So it is 152. 96 plus 103, 199. So 152, 159 again, they become S-curve additions in the subsequent time interval. Okay, carefully need to do it. 152, now 199. Join with the 12th hour, 14th hour ordinates of first stem, and all of them together constitute S-curve additions, S-curve ordinates at subsequent time. And 152 plus 79, how much it is? 152 plus 79. So until it attain equilibrium, you have to do it. 152 plus 79. It is 231. So this is 231. 199 plus 40, it is 249. 231, 249 become again S-curve additions in the subsequent time interval and join with the first stem hydrograph ordinates. Okay, and they become S-curve additions in the subsequent. 231 plus 25, it is 256. 249 plus 7 also 256. Once it attain equilibrium, you can leave it. Once it attain equilibrium, forever it remain with equilibrium. So therefore equilibrium discharge is how much in this case? It is 256 and 256. Once it reaches equilibrium, forever it remain with equilibrium only. no further change happens. Okay, that point you have to notice. So 256, 256. Therefore, S-curve construction is over. This is the S-curve. This is S-curve. Therefore, Q equilibrium discharge is equal to what? 256 meter cube per second. And you have been asked to find out. So S-curve ordinate means S-curve construction. This is only S-curve construction. This is first question answer. This second question answer. This is first question answer. S-curve construction, that is. Construction of S-curve means what? Finding the ordinates only. Equilibrium discharge is this one. Then you have been asked to find out catchment area also. How to find out catchment area? If you know equilibrium discharge, can't you work out catchment area? So Q equilibrium is equal to, it is 2.778 into A by D. So here D is equal to, we used 4-hour into hydrograph. Since 4-hour into hydrograph is used to construct S-curve, D is equal to 4 hours. So Q equilibrium we got already. 256 is equal to 2.778 into A by 4. So therefore catchment area is equal to 256 into 4 by 2.778 kilometers square. That was the answer for third question. So this is how you have to work out. Understood now? So how much it is? 256 into 4 by 2.778. So it is 368.61. Four-hour hydrograph is used, right? So 256 into 4 by 2.778. 368.61 kilometers square is the catchment area represented by this hydrograph. That was the answer for third question. Second question answer. First question answer. Understood now? It is not that simple and easy. So you have to put little effort to work it out. Clear now? So now with the help of this S-curve, we try to work out T-hour unit hydrograph. How T-hour unit hydrograph is constructed with the help of S-curve, let us learn that technique. So first step is very crucial. Next, let us see how to construct So to derive S-curve, we badly require one D-hour into hydrograph. So using D-hour into hydrograph, we derive S-curve. Once S-curve is derived, then we can construct a T-hour unit hydrograph. Then anything related to T-hour term we can find out. Okay? So what you need to do, first step, I'll explain. Okay, let me explain this procedure. So first step is, from the given D-hour into hydrograph, construct one S-curve. From the given D-hour unit hydrograph, construct S curve. Let it be SA curve. Okay, I have named it as SA curve. Construct one more S curve. With a time delay capital T hours. How much hour? Capital T hours. We need to construct one more S curve. Let it be SB curve. So SB curve is delayed by T hours, capital T hours. So we have been asked to construct two S curves. One is SA curve, the other one is SB curve. So it is something like this. You have been asked to derive 1, 2 S curves. One is called SA curve. So SA curve represent a storm of infinite duration starting at the time 0. This one S curve. One more S curve we have been asked to construct with a time delay capital T hours. Okay, capital T hours time delay, one more S curve we have to construct. This is SB curve. How much time delay is there between these two? T hours time delay. So this one is called SA curve and this one is called SB curve. The difference between this SA curve represents storm of infinite duration, right? Starting at the time 0 and end at infinite time period, infinite duration storm. So this constructed by dividing number of storms like this. Okay. Second S curve we are constructing with a time delay capital T hours. Somewhere here we are constructing. This also for both storms end is same, infinity time period only. But beginning is different. End is same but beginning is different. So these two S curves if we subtract, you will get information something related to T hour storm. If you subtract these two, you will get some information related to T hour storm with effective rainfall intensity 1 by D, because this is also 1 by D, this is also 1 by D. Understood? So that's what we try to do. So what we have been asked to do, construct two S curves and with a time delay T hours. First S curve start at T hour time, 0 hour, end at infinite time period. Okay. This is for first storm. First S curve represent one infinite duration storm. Second S curve also represent one more infinite duration storm. But it is delayed by how many hours? T hours. It is delayed by T hours. Therefore, its beginning period is somewhere here. Ending is same for both storms. This is also infinity. So this is SA curve. We took it as this SA. We took it as SB. The difference between these two curves, if we subtract, then what you get is difference between these two S curves. This SA minus SB if you take, you will get one direct runoff a storm resulting T hour duration storm producing a direct runoff R is equal to T by D centimeters. If you subtract these two storms, what you will get? You will get one T hour storm with effective rainfall intensity, right, 1 by D, because this is also constructed with the D hour into hydrograph, D hour. So runoff is equal to 1 by D into T. So it is T by D centimeter. So subtract SA curve, SB curve ordinates from SA curve ordinates from SB curve at respective time intervals to derive T hour direct runoff hydrograph produced by a runoff depth T by D centimeter. Runoff hydrograph resulting from runoff T by D centimeter. So therefore, two S curves if you construct with a time delay T hours and if you subtract them one from the other, what you get is one T hour direct runoff hydrograph. Therefore, T hour direct runoff hydrograph ordinates is equal to, which is nothing but SA minus SB, but it represents a runoff of how much? T by D centimeter. It represents a runoff of T by D centimeter. Okay, that's all. We got direct runoff hydrograph. Once you get direct runoff hydrograph, next step we can derive unit hydrograph. Then derive T hour unit hydrograph from T hour unit hydrograph by dividing T hour direct runoff hydrograph ordinates by runoff R. So therefore, T hour unit hydrograph ordinates is equal to, what are the ordinates of T hour unit hydrograph? Ordinates is equal to, it is T hour direct runoff hydrograph ordinates by R. So therefore, T hour unit hydrograph ordinates is equal to, it is SA minus SB, that is T hour direct runoff hydrograph ordinates by runoff is T by D, and if you simplify, it is SA minus SB into D by T. So therefore, T hour unit hydrograph ordinates is equal to, finally, it is SA minus SB SA minus SB into D by T. So this is how we obtain T hour unit hydrograph ordinate. Understood? Verify, cross check this once you see the procedure. Help? Sir. Okay. Cross check, verify once again. So what you need to do finally, so after constructing the S curve, 2 more steps extra will get. So what are those 2 more steps? So first we construct S curve. Time, d hour unit hydrograph ordinates, S curve additions, S curve ordinates, T hour delayed S curve ordinates, T hour direct runoff hydrograph ordinates, and then finally S curve ordinates will get. That is T hour unit hydrograph ordinates will get. Okay. So finally the method goes like this. So it is time. So d hour unit hydrograph ordinates we post here. Then S curve additions. Then S curve ordinates. This one we take it as SA curve. And T hour delayed S curve ordinates. We'll take it as SB curve. And then we'll get T hour direct runoff hydrograph ordinates, which is equal to SA minus SB, which represent a runoff T by D centimeters. Then we'll get T hour unit hydrograph ordinates, which is equal to SA minus SB into D by T. That's all. This is a procedure. Ultimately, you need to post data in this table and work out the problem. So up to this we have learned already how to plot S curve up to this. Then 3 more columns extra to open. One is delayed S curve ordinates, SB curve. Then difference between 2 S curves and unit hydrograph ordinates you have to derive them. Understood? So one problem on numerical if you take, you can understand better. Okay? Let us solve one question. Shall we take one example? The GATE question. This GATE 2011 question. First question is, come on, try all of you this question. Pi index is equal to 2 mm per hour. So as given options, first question also option is given. Second question also options are given. Catchment area, if you know equilibrium discharge of S curve, you can get it. Or otherwise without that also you can get it. Ordinates are given. When ordinates are given, then using trapezoidal rule you can find out catchment area. Second question, what is given? A uniform storm. It is occurring over a catchment. Okay. For 3 hours time period. But this S curve is the unit hydrograph is given for 2 hours storm. Unit hydrograph representing 2 hours storm, but you have been asked to something related to 3 hours storm. Okay, so 2 hours storm to 3 hours storm you want to travel. So what is given to you is D is equal to 2 hours. 2 hour unit hydrograph is given. So therefore that is taken as D. Then what you have to find out? Something related to 3 hour storm. So 3 hour storm information you have to find out. You have to work out. So therefore what you need to derive? 3 hour unit hydrograph you have to derive. So to derive 3 hour unit hydrograph, right? T is greater than D, first condition is satisfied. N is equal to T by D. So 3 by 2 it is 1.5. Therefore T is not equal to ND. Therefore superposition is not valid. S curve you have to apply. Not valid. Therefore S curve method is used. Since it has failed that condition, S curve method you have to apply this. First you are supposed to have that clarity. So what you have been asked to find out for 3 hours storm? For 3 hours storm he has given P is equal to 6.6 centimeter, T is equal to 3 hours, and pi index is given as 2 mm per hour. For this storm producing some amount of runoff. For that runoff, what is the peak flow due to this storm? Peak flow due to this storm is what? Peak coordinate of 3 hour storm hydrograph you have to find out. So what you have been asked to find out? Peak flow due to 3 hour storm. So therefore this is peak coordinate of 3 hour flood hydrograph or storm hydrograph. That you have to find out. So if unit hydrograph is known to you, so from unit hydrograph you can derive direct runoff hydrograph P minus R by T. This producing So it is 0.2. Point x is given as to mm per hour. So which is equal to 0.2 centimeter per hour. So it is 0.2 is equal to PE is given as the question 6.6 centimeter PE. Runoff is R. This T is 3 hours. So R is equal to 6 centimeter. So this storm producing 6 centimeter runoff. Therefore, if you know, so P coordinate of 3 hour unit hydrograph, if you know, then you can find out P coordinate of 3 hour direct runoff hydrograph, which is equal to P coordinate of 3 hour unit hydrograph into R. To this, if you add base flow, you will get P coordinate of 3 hour flood hydrograph, which is equal to P coordinate of 3 hour direct runoff hydrograph plus base flow. So base flow also given to you 5 meter cube per second. The question only given. Okay, this is how we can find out. So he is asking this. This is the question actually. So what you require for this? P coordinate of 3 hour direct runoff hydrograph is required. To find it out, P coordinate of 3 hour direct runoff hydrograph we require 3 hour into hydrograph is required. So we have to derive first a 3 hour into hydrograph. So then you get P coordinate. Then you can get the rest of the things. So let us derive 3 hour unit hydrograph. Okay, let us go ahead with solving this question. So I will open up the table. This is time. 2 hour unit hydrograph ordinates, then S curve additions, S curve ordinates, these are delayed S curve ordinates, these are direct runoff hydrograph ordinates, this is 3 hour unit hydrograph ordinates. Okay. So time, this is given 2 hour unit hydrograph ordinates are given to you at 1 hour time interval. Then we will find out S curve additions. Then from here we will get S curve ordinates. This only will take it as SA curve. Then how many hours you have to delay? 3 hour delayed. T is equal to 3 here. So here T is equal to what? T is equal to 3 hours, D is equal to 2 hours. Therefore, 3 hour delayed S curve ordinates. 3 hour delayed S curve ordinates. This is taken as SB curve. Then if we subtract both of them, what will get? 3 hour direct runoff hydrograph ordinates, which is equal to SA minus SB. Then 3 hour unit hydrograph ordinates will get. So 3 hour unit hydrograph ordinates is equal to SA minus SB into D by T. So D is equal to 2, T is equal to 3. 2 by 3. You have to multiply. So D is equal to 2, T is equal to 3. So D by T it is. So 2 by 3. So every 1 hour time interval ordinates are given. 0, 1, 2, 3, 4, 5. How many ordinates are given here in the question? So 1, 2, 3, 4, 5, 6, 7. 7 ordinates. 0, 3, 8, 6, 3. 0, 3, 8, 6, 3. 0, 3, 8, 6, 3. 0, 3, 8, 6, 3. 2 and 0. Okay. It's 2 and 0. 1, 2, 3, 4, 5, 6, 7. Right. So it is first hydrograph. First step is very crucial. This is 2 hour unit hydrograph. So second hydrograph join with first hydrograph only after 2 hours. So about 2 hours, whatever ordinates are there, they straight away become S curve ordinates. So these two become straight away S curve ordinates. So they are 0 and 3. So these 0 and 3, they become additions in the subsequent time interval. Go and join with these 8, 0, 6, 3. Then this become 8 and 9. 8 and 9 again become S curve ordinates in the subsequent time interval. Join with the first storm hydrograph ordinates. 8 plus 3, 11. 9 plus 2, 11. So it attained equilibrium. Once it attained equilibrium, forever it remain in equilibrium only. Therefore, equilibrium discharge of S curve is 11. So once you get equilibrium discharge, you can find out. So Q equilibrium is equal to, it is 2.778 into A by D. So we got this is 11, 2.778 into catchment area is unknown. D is 2 hours. Therefore, catchment area is equal to, it's 11 into 2 by 2.778 kilometers square. That's how you can find out. Once you get equilibrium discharge, you can find out. Oh, it's your first class. Okay, thank you. Did you attend from the beginning? SK? So because this step only very crucial. Here if you see graphically, this is first hydrograph. The ordinates are 0, 3. What are the ordinates given there? 0, 3, 8, 6, 3, 2. Every 1 hour is given. 0, 3, 8, something like that. 0, 1, 2, 3, something like that. Second hydrograph join with first hydrograph only after 2 hours. Right? This is second hydrograph join here 2 hours. So again 0, 3, 8 like this. So whatever ordinates are there before 2 hours, they straight away become S curve ordinates, because S curve start from 0 only. This is S curve. This will go like this. So before 2 hours, whatever ordinates are there for first storm hydrograph, they become S curve. They become additions in the subsequent time interval. See now 0, 1. So before 2 hours, 0, 1 are there. 0, 3. That 0, 3 become S curve additions in the subsequent time interval. Join with the first storm hydrograph ordinates. What are the first storm hydrograph ordinates? In the year, whatever ordinates are there here and here, they join. Again, these become S curve additions in the subsequent time interval here. And join with these ordinates. So like this, it keep on going. So that's what we did graphically. Understood? Just to give idea to you. That's what we did here. Clear now? SK? So Q equilibrium you got. From Q equilibrium also you can find out. Otherwise, without Q equilibrium also you can find out. Without knowing Q equilibrium also, because all these hydrographs represent same catchment. 2.778 into A by D. D is equal to here 2.778. Q equilibrium is 11 into 2 by 2.778. So it is 7.9 kilometers square. So Q equilibrium discharge is how much it is? 7.9 kilometers square. Given options, it is there already. Or otherwise, you can also use trapezoidal formula to work out equilibrium discharge. So Q equilibrium is equal to 7.92. Actually, how much I got? 7.919 I got. So it is rounded to 7.92. 7.919 I got. 7.919. So rounded to 7.92. Or otherwise, you can also work out Q equilibrium discharge without knowing the equilibrium discharge also. So without knowing equilibrium discharge, how to find out? Using trapezoidal rule. You can apply non-linearly shaped hydrographs. When ordinates are given, area under the curve you can measure by using trapezoidal rule. So catchment area is equal to catchment area represented by this hydrograph is equal to, it is volume of runoff by depth of runoff. What is volume of runoff? Area of 2 hour unit hydrograph. That's only given to you know. Since it is 2 hour unit hydrograph, depth of runoff represented is 1 centimeter. If you divide this by 10 power 6, straight will get answer in 10 kilometers square. So how to find out? So when ordinates are given, delta T into first ordinate plus last ordinate by 2. plus sum of the remaining ordinates. This is trapezoidal rule because it is non-linearly shaped hydrograph into 1 by 100. This is runoff, depth of runoff, because since unit hydrograph 1 centimeter converted into meters into 1 by 10 power 6 kilometers square. This way also you can find out. Delta T means what? Time interval between these. Time intervals. The time interval between these is called delta T. These time intervals are called delta T. These are called delta T. Understood? From here to here, here to here, this is called delta T. Time interval between the ordinates. So they are called delta T. So delta T is 1 hour. So it is 1 into 60 into 60. So first ordinate and last ordinate zeros. Remaining ordinates are 3 plus 8 plus 3 plus 8 plus 6 plus 3 plus 2. First ordinate is 0. Last ordinate also 0. Remaining 3 plus 8 plus 6 plus 3 plus 2. Non-linearly shaped hydrograph, trapezoidal rule you can use. By 1 by 100 into 1 by 10 power 6. This also will give same answer. That way also you can do. Come on, find out. So it's 3 plus 8 plus 6 plus 3 plus 2. 3 plus 8 plus 6 plus 3 plus 2. 22 into 1 into 60 into 60 into 100 by 10 power 6. So 7.92 kilometers square. Same thing you got now. So without working out like this also, if you know equilibrium discharge also, you can find out catchment area. Here also you got, without working out like this, we worked out catchment area using equilibrium discharge, using this equation. Understood? This way also you can find out. Anyway, we have to work out. So now let us delay 3 hours. 3 hours means what? 0 of S curve, second S curve should come at exactly. So before 3 hours, no ordinates are there. Remaining ordinates post as it is. 0, these S curve ordinates only. 3, 8, 9, 11, 11. Any number of times it is 11 only. After that, nothing. Subtract both of them. 0, 3 minus nothing, nothing. 3 only. 8 minus nothing, 8 only. 9 minus 0, 9. 11 minus 3, 8. 11 minus 8, 3. 11 minus 2, 0, 0, 0, 0. Then afterwards, any number of times. Multiply all these ordinates with 2 by 3. So 0 into 2 by 3, 0. 3 into 2 by 3, 2. This is 16 by 3. 9 into 2 by 3, 6. 16 by 3. 3 into 2 by 3, again 2. This 4 by 3, 0, 0, 0. So he is asking what? P coordinate. So among this P coordinate is what? 6 only. 6 is the P coordinate among all these maximum ordinate. P coordinate is maximum ordinate. Therefore, we can work out. So P coordinate of 3 hour unit hydrograph is equal to P coordinate of 3 hour unit hydrograph is equal to, it is 6 meter cube per second. Therefore, P coordinate of 3 hour direct runoff hydrograph resulting from the real storm is equal to, so P coordinate of 3 hour unit hydrograph into R. So runoff produced by that storm already calculated here. So how much runoff it is producing? 6 centimeter runoff. So that runoff value if you multiply, we will get P coordinate of this one. So 6 into 6, it is 36 meter cube per second. So what he is looking for, he is not looking for direct runoff hydrograph. He is looking for flood hydrograph or storm hydrograph. So therefore P coordinate of 3 hour flood hydrograph is equal to, it is P coordinate of 3 hour direct runoff hydrograph plus base flow. So it is 36 plus 5, it is 41 meter cube per second. That was the answer for this question. So this question is asked for 4 marks. One is 2 marks for working out catchment area, 2 marks for finding So 41 meter cube per second. Options given are 41 meter cube per second, 43.4 meter cube per second, 53 meter cube per second, 56.2 meter cube per second. Therefore 41 meter cube per second is the right. He did not mention you to use S-curve method or something like that, but without S-curve method you can't solve this question. So that is the beauty of GATE questions. So first of all you need to understand, so what is to be done with this problem. So based on that you have to think and analyze. So what exactly is looking for, based on that you have to decide which method to be used. Blindly you cannot work out the problems in GATE exam. Understood? Clear? So I'll show you once again, explain you this problem. So what he's asking is, he's asking peak coordinate of 3-hour flood hydrograph. Peak flow due to 3-hour storm and this is. So until you know unit hydrograph ordinates, you can't find out. Unit hydrograph ordinates, if you know that, you multiply with R, you will get direct runoff hydrograph ordinates. To that base flow you add, you will get peak coordinate of 3-hour flood hydrograph. To find out that peak coordinate of 3-hour unit hydrograph, we force you to use S-curve method. Why S-curve method means what is your take? So since I wrote here already, since T is greater than D, T is not equal to D, so the superposition is not valid, therefore S-curve method is used. We have to use S-curve method to work out something related to this term. That justification I gave at the beginning of the question only. So it is a 4 marks question. Clear now? The justification I gave here in the beginning only. He is asking something related to this term. What is that peak flow due to this term? What is that peak flow due to this term? This is peak coordinate of 3-hour storm hydrograph or flood hydrograph. He is asking that. Due to this term is producing how much amount of runoff? That I calculated here. Runoff produced by this storm is 6 centimeters. So this runoff produced by this storm is 6 centimeters. For that storm, peak coordinate of 3-hour storm hydrograph. Okay? Understood? Nowhere he mentioned that use S-curve method or something like that. With your intuition you have to decide which method is the best to work out this problem. If T greater than D, T is also equal to ND, you can also use superposition. So once you fall in love, once you understand this S-curve method, so once you digest this method, you no more use superposition, because all problems you can solve by superposition, you can also solve by S-curve method. So we no more apply superposition. Once you understand the S-curve concept. Okay? So we'll see a few more problems tomorrow. I may not take tomorrow. I have got a training to start plus classes, because I don't know how to launch plus classes, special classes and all. So they give me training tomorrow. Then again I'll meet on Tuesday, day after tomorrow, probably at 8 o'clock in the night I'll meet. Day after tomorrow we'll meet, Tuesday. Okay. So I'll take one more S-curve question, good question, GATE question. Then with that we'll close this topic. Then we'll see next topic. Okay then. आप सबका मकर संक्रांति, what do you call Hindi? I am trying to speak you in Hindi. मकर संक्रांति शुभकामना आप सबको. Okay? Celebrate and enjoy. Okay, before I close, okay, some promotional content is there here. Okay guys, let us meet sometime in future.